Okay. Okay, good morning. My name is Awan. I'm going to present to you about automatic fan temperature. Now, intro greenhouse, or better known as a greenhouse, is a building made of glass or plastic that allows growers to be sheltered or controlled. The heat from the sunlight penetrating its transparent structure heats the plants and the soil within them. In addition, the air inside is also heated and remains inaccessible to get out of this building, which means the air is contained inside the building. So for the project background, this project is used for agriculture and can be used specifically to farmers that are using greenhouse for their plants. This project uses automation and is very useful for not only greenhouse users but also others, for people that want to use fan automation. The problems with these projects are the system does not detect heat in a greenhouse accurately, and it cannot be controlled manually. Next on, we go to objective. The objective of this project is to create a project that can monitor the temperature and change the temperature manually whenever you want. The other objective is a successful automation project where you can monitor the greenhouse. So the purpose of the project is to monitor the greenhouse from a distance and to change the temperature, such as greenhouse conditions at a certain temperature, and to avoid any disturbance in the greenhouse. Now, we're talking about the project scope. For the hardware is one-way relay. You require two one-way relay, jumpers, PCB board, a BMP 180 barometric pressure sensor, which I will get to you later, two 12 volts DC fans, ARDUINO Uno, and a 12 volt adapter. For the software, you're going to use Arduino IDE. The testing and measurement is temperature. So going on with the components, this is a BMP 180 barometric pressure sensor. This precision sensor from Bosch is the best low-cost sensing solution for measuring barometric pressure or temperature. It's mainly used for atmospheric pressure, but it also can be used for heat as well. The use for BMP 80 model is further promoted with altitude measurement, high-speed sensor, and temperature sensor on board than other modules. Next, we're going on for the Arduino Uno. It's a low-cost, flexible, and easy-to-use programmable open-source microcontroller board that can be integrated into a variety of electronic projects. It also can be interfaced with other Arduino boards, Arduino Shields, Raspberry Pi boards, and can control relays, LEDs, servos, and motors as an output. Next, we're going to look at a one-way valve. This is a one-way valve. It's an electromagnetic switch, can be operated by a relatively small current that can control much larger current. Next is the 12 volt adapter, which can be used for anything such as laptop computer, lighting, mobile equipment, and many more. Now we're going on with the methodology. So for the first method that I'm going to use on my project is the cooling method, which can be done by opening windows, but for me, I will use it by using ventilation fans in the greenhouse when it is too hot for the plants in it. This can be done manually, automatically, and due to temperature difference, or can be opened by a electronic controller. This is my GANT chart. As you can see, is 100% done during February. This is my study flow chart. Next, we're going to look at the programming flow chart. So from the start, the BMP sensor is in ready state, and when it sends heat, when heat increases, the BMP will detect it, and it will open the first relay and the second relay. Same goes with the first fan, fan 1 and fan 2. And it will go to the plant. And it will cool the greenhouse down. This is the estimated cost of my project. For the Arduino, it costs like 38 ringgit. For the BMP 180, it doesn't cost a lot. It is strong and very flexible, but it only costs 5 ringgit. For the one-way relay, it only costs 5 ringgit as well. The DC fan costs 16 ringgit. The 12-volt adapter costs 11 ringgit. The PCB board is easy to find. It costs around 9 ringgit. Even jumpers is easy to find. It costs around 3. So all together is around 88 ringgit. Going to analysis. For the first week, for the first week till the 6th week, I tweaked my BMP 180 sensor. It has a slight problem with the sensor because I need to adjust the temperature level, and I got it done in the 9th week. So for the Arduino Uno as well, from the first week to the 9th week, I have no problems with it. As for the fans, the first week and the 3rd week, I had a lot of problems because I use a low voltage power to power up the fan. And for the 5th until the 9th week, I figured it out how to power the fan using a 12-volt adapter. Next is the recommendation. For me, to make this project work for future automations, I would add heat automations in case it is needed to warm up the greenhouse. Furthermore, I would make it more secure. I would recommend a security system if there's any pests that would destroy the crops. Next is the conclusion. During this time, a lot of resources are getting lower, such as food imported from other countries, and less people working because of this COVID-19 situation. My purpose of this project is also to let people know how useful automation is. Would it be if it were to be used in the field instead of manpower and taking risks of the crisis that is COVID-19? My RUJUKAN and LAMPIRAN. So next, this is my project. So you can see here on top is my components, and the sides are the fan that is hanging to the wood. This is my circuit design. As you can see, the 5-volt is powering up the relay, while the 12-volt is powering up these two fans. The BMP sensor is powered up by the 5-volt as well. Next, creativity. I would how you say this? So I feel this project is not only used in greenhouse, but it can be also used in houses that needs fan automation and such. I think that's all. So next is the demonstration of the project. Okay, so if we look at the front, that is the temperature if the fans are off. So what will happen if the temperature were to be hot? So the sensor will be hot and the fan would be on. Same goes with the relay.
So this one, where do you put it in your greenhouse?
It goes to put it on top. This is a small, what's that? This is a small, how you say, presentation, but it can be bigger.
So this one is facing inside the greenhouse.
Yeah, it's facing inside the greenhouse.
So the fan is actually blowing
down. It's also actually blowing down.
I thought you said that you're going to blow the fan, blow the air outside.
No, because the temperature is contained inside. So the purpose of the greenhouse is to maintain a certain temperature.
Okay.
So this is a sensor. So whenever it hits 30 temperature, like in the front,
Okay.
it will blow up.
Jadi maknanya kos perempuan ni memang
Kecil.
kalau dalam keadaan sebenar
If a real, kalau keadaan sebenar dapat guna kipas yang lebih besar,
dalam kosnya dah jadi lain.
kos jadi besar.
No, actually,
Ini for prototype.
I think you can use this, but you have to. Okay, I've read about now, right? So they trap the heat inside.
Yeah, they
so
trap
if
the
you
heat.
want to cool it down, the best way is to open up one of the fans so that air can flow outside, so it can cool it.
Yeah.
Kalau ini ya, ini masuk je kan. Ini masuk keluar.
There's also another method where you can use the ventilation fan.
Heating dalam satu minit keluar. Mana dia masuk angin, satu
One goes out.
Yeah, it's kind of like
dia ada circulation lah.
like this, right? See the vent? It blows the hot air.
Inside, then it goes outside.
So because I don't really see how do you put this into the project. Is there any way that you can take a video of this stay inside some sort of greenhouse? So we can,
So you can on it.
yeah, you take a video and then you send it to us.
Okay, sure.
So that we can see the full operation. Because I know how this thing works.
Mm-hmm.
It's just that from a perspective of kekemasan, this one pakai kotak kan.
This one's supposed to be on top, right? This one's supposed to be.
Yeah, you can put it on top or whatever. You can create a panel wherever inside the house. So this first one, you can see kantong. There's no fixed place for it to put. Right. So kemasan memang beda lah.
Itu saya macam tadi.
Ya.
Kalau yang ada dalam ketemukan angin untuk pendidikan, satu lagi kipas untuk mengeluarkan udara panas. Udara panas ini kan ya, yang udara sejuk ke bawah, udara panas ke belakang. Betul. Itu sebabnya kalau kita tengok exhaust fan, dia di belakang. Kalau udara panas akan tengok. Dia keluarkan yang mana ni boleh satu untuk mungkin dalam untuk pendidikan ni kena bawah sikit tau. Yang ni kena di atas.
Kalau dia keluar. I could add a delay, for example, like so this one the cool air will come in and then a delay so they go out.
There's a lot of lacking lah. You can see.
So that's all for me. Thank you very much.
Okay, I'll do some comments. First of all, let's go back to your slide. Okay, you're saying the title part. You're saying this is automatic fan temperature. Actually, it's not precise because your scope is in greenhouses, right? So you have to say automatic temperature control in greenhouses. You have to put your scope inside. So what you're putting it on, right? Okay, so that's the first one. The second one is to go to your problem statement. Okay, problem statement lah. This is the operator lah. Problem statement. Pecahan masalah. Okay, so the system does not detect it in greenhouse temperatures. Okay, it actually is not really the case of detecting it. It is the case of recording it. Recording is the term. Okay, the system does not record heat in the greenhouse temperature. The second one is if it's too short. The the sentence that you're using is fragmented. You have to say a greenhouse temperature is a normal, a usual, a typical greenhouse control system does not control the temperature manually. You have to put a full sentence because your problem statement it will link to your objective kan. Okay. So let's go to your testing and measurement dekat scope, project scope. Okay, so this one I think testing and measurement you have to put what you are using to test. Is it thermometer? Is it your LM sensor compared with the ARDUINO? Right? So you have to put your sensor lah. If you're using sensor, then you use sensor. Okay, what kind of sensor? Okay, so chapter 2, part 2. Okay, actually you have to segment your slide. Bab 1, bab 2, bab 3, bab 4. You have to name. Alright, so this component, I think not enough explanation or specification, table, discipline table, tech sheet, what does it do, how does it do things. Those parts are lacking. And I think it might also be lacking in your report. So you have to put if you see Fatin Mina, she explained everything very detailed. Okay? Because second chapter tu, bab 2 tu, you have to have your study. That means your study. If you put less, that means that you're not reading as much. Kan? Okay? Also go to your one-way. Okay, this is not one-way valve. This is not one-way valve. This is an SPDT relay. Okay? SPDT relay. It's called SPDT relay. Before double nothing. I'm not sure what this key was. Okay? SPDT relay. That's the correct name of the conference. Okay, you don't teach now. Okay, so go to your methodology. Okay, your methodology is lacking visuals. You have to show how the airflow works in the greenhouse. How the air circulation, when you want to heat it up, how the air circulation works. When you want to cool it down, how the air circulation works when the fan is turned on. Okay, that is what is lacking. That is why I don't get how the cooling works up, because you don't portray it visually. Okay, so next is the GANT chart. Okay, I noticed there's a huge gap. What have you been doing in the gap there?
Usually, for this part, it's actually the pelaksanaan.
Oh, but you did not. You did not label it. Okay, because even compared to your senior, you have a lot of time to do this project. I think you have an advantage of for about 4 weeks now. 4 weeks to extra to do this project. So actually, what you showed here, I'm going to be very honest is SAPA lah. SAPA. Okay, you have to show more effort because this is your final year project. It is not project for your course, other than your course. Right? Okay, so let's go to your programming flowchart. This one is okay. This one is incomplete because when you have a diamond, you need to have more than one arrow. Okay? The text hit, or it's not the text hit. I want the diamond one to be more specific. Records hit for more than 50 degrees. You say criteria is 50 degrees, right? Yes. So then the temperature is more than 30 degrees, go down. Less than 30 degrees, go up. Back up, right? Go back up. Okay? Back up somewhere. Make it a loop because your programming is always in a loop somewhere. Okay, so it's complete. Let's see to your graph now.
Which graph? This one?
What is this graph actually?
Is my analysis for what I did.
Oh, it's the progress, is it?
Yeah, the progress.
Project progress. Oh, so it's not your hasil lah. This is the project progress, meaning that for what is the blue one I can see?
The BMP sensor.
Okay, so the BMP sensor, it goes up and then suddenly down. What does it mean? I don't get it.
I had to tweak it a bit because.
Oh, you have to tweak it. Okay, so meaning the progress got pushed back because of the some error lah. Okay, so this one is not the analysis of your project. Okay. So what I want for analysis of the project is you trace back to your objective. Can you see your objective back? Okay, this is what I want. Okay, create a project that can monitor the temperature and change the temperature manually to whatever you want. In your analysis, you have to show me how you do this. How has your project managed to achieve this? Also the second one. Okay? Both of them. If you say you can monitor the temperature, so how do you say you can monitor? Is it by a SG display? Or is it via an app? Because right now I cannot see that the temperature is how much, right? We can only see that if it exceeds 30 degrees, the fan will turn on. But I don't know how exactly the temperature is at one moment of time. What's that? Okay?
Why if I say it uses this laptop for the serial monitor?
Okay, but you have to show it. You have to show it. If you're using a serial monitor, then in your results analysis, you have to show the print screen of the serial monitor. Temperature. Okay? Temperature. And what is it doing? Is the fan turned on? Is the fan turned off? Right? Okay? Walaupun in reality, I don't really like people using the serial monitor because it is for testing purpose, isn't it? In a more product purpose, you have to use some sort of LCD, or you have to write your own software to read. Right? And next, go to your result. Because you are lacking results now. I can see this thing works, but it is not the result that we want, because you have to compare it to your objective. Right? Okay, so you can say that what is lacking here is you don't have any results that can be compared to your objective, and then you can say whether your objective is achieved or not. Because the whole point of your PTA is to see if your objective is achieved or not. Yes, you get it right? Okay. Right, so go to your yang ada your references. Okay. Consistent lah, if it's English references and appendix. Alright. Okay, so this one, label it number using numbers. Okay. And also do citation. Do you know how to do citation?
No.
Okay, if you open up your bab 2, there's words there. ARDUINO Uno is a type of code. This, right? You have to put the label number where you take it from. That statement. You get the one, right?
Right.
Okay. Okay. So next, you see a circuit design in your. This one you have to put in bab 3, not in the end. This is not lampiran. Lampiran is your program code. That is the lampiran.
Oh, okay.
This one is very important for your project. So it's in bab 3. Okay? So in bab 3. Okay? I think that's about it lah. You may comment lah.
Satu lagi yang ni penulisan ni, jangan campurkan bahasa Melayu dengan bahasa Inggeris. Bahasa Inggeris semua. Semua dalam bahasa Inggeris. Jangan campur.
But I have to give credit because you have confidence in your presentation skills. It's pretty good. It's just that your slide, your project, and your writing is not yet up to standard lah. Okay, we have to keep the standard around here, right? So if you have how many minggu we have? Okay, you have 1 week to fix all this lah.
Terutama saya penulisan bagi sebenar lah sikit. Okay?
Because I saw your name in the list. I think it's almost borderline cemerlang, but you're not there yet. So if you can bump this up, you can actually make it to the cemerlang list lah.
Tapi sempat lagi kalau macam tu penambahbaikan sempat lagi kan?
Betul.
Sempat lagi kalau ni untuk penambahbaikan.
Belum rata.
Dah penambahbaikan projek ni boleh lagi kan?
Lagi
Sebab itu boleh masukkan dalam ni.
Lagi belum minta markup. Boleh. We still give you chance lah. Actually, if you go to you ke apa kan, this is the final moment where your bugs are sealed. So there's no more coming back, but we're still going to give you more chances because this is the only chance.
Confident ada tapi isi tak. Isi kurang, bukan tak ni kurang apa? Tak sepatutnya untuk cemerlang, memang kena bagi yang lebih lagi lah.
Boleh rujuk. But Fatin writing is very good. You can take some of the inspiration from there. Okay.
Okay. Okay.